So what's the simplest, most perfect solid shape you can possibly imagine? It's got just 4 faces, and it's this fundamental building block of our 3D world. Today, we're going to dive into the tetrahedron. It's the very first of the 5 Platonic solids, those perfectly symmetrical shapes, and we're going to figure out how you can actually make one.
I mean, just look at it. It's defined by its perfect simplicity. You've got 4 faces, and each one is an identical equilateral triangle. 6 edges, all the exact same length. You can kind of think of it as the atom of 3-dimensional space. It's the most basic solid building block that can even exist.
Now, it looks simple enough, right? But actually creating this perfect shape is a really fun little puzzle. And as we're about to see, the solutions are surprisingly clever, using things you might literally have on your desk right now.
All right, our first method is surprisingly easy, and it starts with something you probably have lying around the house, maybe even in a pile of junk mail. That's right, a totally standard sealed envelope. This humble piece of paper holds the secret to our first construction, and it just takes a clever bit of paper folding. So the goal here is to create what's called a net. Think of it like a flat blueprint that, when you fold it up, creates a 3D shape. And believe it or not, with just a few precise folds and a single cut, an ordinary envelope can become the perfect net for a tetrahedron.
Okay, so everything starts with this one simple fold, right down the middle. This gives us a crucial reference line, and that's the key to making sure all our other folds and angles are just right.
Now here comes the clever part. This specific fold, bringing the corner right to that center line, automatically creates a perfect 60-degree angle. And that's exactly what we need for our equilateral triangle faces. No protractor required. It's pretty cool. A couple more quick folds to find the other faces, and then one single snip removes the extra paper. And just like that, our net is totally complete and ready for its transformation. Now for the fun part, you just fold along the creases you made, tape up the edges, and that flat envelope springs to life as a perfect tetrahedron. It's a fantastic piece of everyday mathematical magic. You've got to try this one. Okay, so that was building a tetrahedron up from a flat sheet of paper. But what if we took the complete opposite approach? Instead of adding and folding, let's try subtracting, carving.
This is honestly one of my favorite geometric facts. It turns out that a perfect tetrahedron is secretly hiding inside another Platonic solid, the cube. They have this hidden, really intimate relationship.
I want you to imagine taking a cube and connecting 4 of its corners. The trick is you have to make sure no 2 corners you pick are on the same edge. Those connections perfectly outline a tetrahedron right inside. To reveal it, you would just slice off the 4 little corner pyramids that aren't part of the shape. And this relationship reveals a totally mind-bending mathematical truth. The volume of that tetrahedron you just carved out is exactly 1/3 the volume of the original cube. I mean, it doesn't look like it should be such a clean, perfect fraction, but the geometry is just elegant. So we've gone from folding paper and carving solids. Let's jump into the 21st century. How can modern tools help us build this ancient, perfect shape?
So with this method, we're going to completely ignore the faces and just focus on the shape's skeleton. We're building it from its most basic parts, its 6 edges, and its 4 corners, or what we call vertices.
And this is where tools like 3D printing come in. We can design and print these custom vertices that hold the edges at the exact angle we need. And for you geometry fans, that angle between the faces, the dihedral angle, is about 70.5 degrees. Once you have those, it's just a matter of snapping in 6 identical sticks to form the skeleton.
And the result is this clean, precise, beautiful representation of the geometric form. You'll notice it's the same perfect shape we saw at the very beginning, just brought to life through a completely different method.
Okay, for our final exploration, we're going to touch on a really profound geometric idea called duality. As we're about to see, the tetrahedron has this very special, almost magical property related to this concept.
So, what in the world is a dual? Well, imagine any Platonic solid. If you find the exact center of each of its faces, and then you connect all those center points, the new shape you create on the inside is the dual of the original.
Let's try to visualize this with a model. Imagine these bottles are representing lines coming from the exact center of each of the tetrahedron's 4 faces. Okay, so now what happens if we connect the tips of those bottles? We're connecting the 4 center points of the original faces. What shape do you think we're going to create? The answer is another tetrahedron.
This is just incredible. Of all the Platonic solids, the tetrahedron is the only one that is its own dual. It contains a perfect, smaller mirror of itself. It's like a shape in perfect dialogue with its own geometry.
So, we've folded it from an envelope, we've carved it from a cube, and we've built it with modern tools. We've even seen how it contains a perfect little mirror of itself. Which really just leaves one final question. Is the tetrahedron a simple shape, or is it a profoundly complex one, just hiding in plain sight?